Swayam Prabha. Digital India. Educated India.
Welcome to lecture 34 on time series modeling and forecasting. In the last lecture, we discussed the stationarity of multivariate time series processes. For univariate time series processes, if the process is stationary, then the wall decomposition says that you can write the process as a moving average process of infinite order. Another representation of wall decomposition writes the stationary process as an ARMA process. Similar kind of representation can be extended for multivariate time series processes. If your process is stationary and it satisfies certain very general conditions, then you can write the multivariate process as a vector form of moving average process of infinite order, or as multivariate extension of ARMA processes. In this lecture, I will also discuss the stationarity and invertibility conditions for the vector moving average processes, or vector autoregressive processes, or vector ARMA processes. So, now we consider vector autoregressive moving average model or VARMA model. Before that, the word infinite moving average representation of any stationary multivariate process is y t minus mu equal to summation j equal to 0 to infinity psi j u t minus j. And then you can also write psi b as psi b equal to phi b inverse theta b, where phi b is equal to 1 minus phi 1 b minus phi 2 b square minus 1 minus phi p b to the power p. This is a matrix polynomial, and theta b is equal to 1 plus theta 1 b plus theta 2 b square plus 1 plus theta q b to the power q. This is also a matrix polynomial. Here phi j for all j equal to 1 to p is a k by k autoregressive coefficients matrices. Then theta j's are k by k moving average coefficients matrices. Y t is a k by 1 vector of your multivariate time series. U t is k by 1 vector of white noise with expectation of u t is equal to 0, and expectation of u t transpose is equal to sigma. So, sigma is the variance covariance matrix of u t. Now, it leads to the following vector autoregressive moving average process of order p q. Phi b y t minus mu equal to theta b u t, or y t is equal to delta plus summation j equal to 1 to p phi j y t minus j plus u t plus summation j equal to 1 to q theta j u t minus j. So, this is just a multivariate extension of ARMA PQ process, and this is called vector autoregressive moving average process of order p q. P is the order of the autoregressive term, q is the order of the moving average term. Then if you take expectation of y t and suppose expectation of y t is equal to mu, then expectation of y t is equal to, say, since the process is stationary, mu does not depend upon t. So, on left hand side you get expectation of y t equal to mu equal to delta plus, then expectation of each of these y t minus j's is equal to mu. So, you get mu times summation j equal to 1 to p phi j. Then expectation of u t is 0 and the expectation of this last term is also equal to 0, because expectation of each of u t minus j's is equal to 0. And then from here you obtain mu equal to delta into 1 minus summation j equal to 1 to p phi j inverse, or expectation of y t equal to mu is equal to 1 minus phi 1 minus phi 2 minus so on minus phi p inverse delta. Or you can write delta equal to 1 minus phi 1 minus phi 2 so on minus phi p mu. In fact, you can also write this delta as phi I mu. Because here you can take b equal to I, or you can also take b equal to 1. So, you can also write it as phi 1 mu. So, both are correct. You can also write it as phi 1 mu or phi I mu, but for both the cases you get 1 minus phi 1 minus phi 2 so on minus phi p. We consider the stationarity and invertibility conditions of vector ARMA processes. Now, if the process is invertible, then it can be represented as a convergent vector autoregressive process of infinite order. Is the same condition you have for the univariate time series also. If the process is invertible, then you can write any moving average process or any ARMA process in the form of a convergent autoregressive process of infinite order. Similarly, for vector processes also, the process is invertible if you can write it as a convergent vector autoregressive process of infinite order. So, you can write it as y t equal to delta plus summation j equal to 1 to infinity pi j y t minus j plus u t. Or you take just all these terms involving lagged values of y t towards the left hand side. So, you get pi b y t equal to delta plus u t. And we assume that summation over j equal to 1 to infinity, this norm of pi j is less than infinity, and pi b is equal to 1 minus summation j equal to 1 to infinity pi j b to the power j theta b inverse, and then you can write it as say theta b inverse phi b. Then the process is stationary if it can be represented as a convergent vector moving average process of infinite order. So, for a stationary process you get this representation y t equal to mu plus u t plus summation j equal to 1 to infinity psi j u t minus j. Or you can write it as y t equal to mu plus psi b u t, and then we have the assumption that summation over j equal to 1 to infinity norm of psi j is finite. So, that we have represented y t as a vector moving average process of infinite order, and the process is convergent also because of this condition summation over j norm of psi j is finite. Here psi b is equal to 1 plus summation j equal to 1 to infinity psi j b to the power j, and then you can write it as phi b inverse theta b. Let determinant of a matrix A is denoted by DETA. This notation we are using for the determinant of a matrix A, and we denote the adjoint of a matrix A by this notation. So, ADJ A. So, this gives the adjoint of a matrix A. Then the inverse of a matrix A is defined as determinant of A inverse adjoint of A. So, you can write phi z inverse equal to determinant of phi z inverse phi star z, where phi star z is the adjoint of phi z. Then you can write the process as y t equal to mu plus determinant of phi b inverse phi star b theta b u t. Then phi star z theta z is a polynomial of finite order in Z. So, the stationarity of the process depends upon this part, determinant of phi b inverse, and if this part is convergent, then the process is stationary. So, you say that the process is stationary if determinant of phi z inverse is convergent for mod z less than 1. So, we just concentrate on the inverse of determinant of phi z. Now, phi z is of order p cross p. So, obviously, determinant of phi z is a polynomial of degree p in Z. So, suppose psi 1 inverse, psi 2 inverse on psi p inverse are the roots of the equation determinant of phi z equal to 0. Then you can write determinant phi z as 1 minus psi 1 z into 1 minus psi 2 z into 1 minus psi p z. And then determinant of phi z inverse is convergent for all mod z less than 1 if the roots psi 1 inverse, psi 2 inverse, so on psi p inverse lie outside the unit circle. In fact, you can write the determinant of phi z as 1 upon 1 minus psi 1 z, 1 minus psi 2 z, 1 minus psi p z, and then this can be written as using partial fractions summation j equal to 1 to p, and you have some constant say k j here upon 1 minus psi j z. So, this is the determinant of phi z inverse, and then you can verify that each of the term of this equation converges for mod z less than 1 if psi 1 in psi 1, psi 2, so on psi p are less than 1 in modulus. So, each psi j is less than 1 in modulus, or each psi j inverse mod of each psi j inverse is greater than 1, or each root inverse or each root lie outside the unit circle. Again, the process is invertible if we can write the process as an autoregressive process of infinite order. So, along the same lines, you can easily verify that the process is invertible if all roots of the determinant of theta b equal to 0. Say these roots are eta 1, eta 2, so on eta q lie outside the unit circle. The proof of this invertibility part is just similar to the proof of stationarity part. Now, suppose in vector autoregressive moving average process of order p q, we take mu equal to 0. Then we can write the model as capital phi b y t equal to capital theta b u t given in equation 1. Further, we write k equal to k 1 plus k 2, and then we partition capital y t, capital phi b, capital theta b and u t as y t equal to y 1 t, y 2 t, where y 1 t has k 1 components, y 2 t has k 2 components. Further, phi b is equal to phi 1 1 b, phi 1 2 b, phi 2 1 b and phi 2 2 b. Similarly, we partition theta b as theta 1 1 b, theta 1 2 b, theta 2 1 b and theta 2 2 b, and ut is equal to u 1 t, u 2 t. And then suppose we take phi 1 2 b equal to 0, theta 1 2 b equal to 0, and then we also take theta 2 1 b equal to 0. Now, since we have taken phi 1 2 b equal to 0, theta 1 2 b equal to 0 and theta 2 1 b equal to 0, the first k 1 equations of the process becomes phi 1 1 b y 1 t plus the second term phi 1 2 t, phi 1 2 b y 2 t becomes 0, and on the right hand side you have theta 1 1 b u 1 t, and then the second term involving theta 1 2 b is 0. The second equation is, which involves the next k 2 time series, is phi 2 2 b y 2 t equal to minus phi 2 1 b y 1 t plus theta 2 2 b u 2 t. Now, from these equations you can say that y y2t is caused by y1t, or y1t are said to cause y2t, but y2t do not cause y1t. This equation does not involve y2t. So, y1t causes y2t, but y2t does not causes y1t. So, here actually y1t is your exogenous variable for this second equation. And this model is referred as an Rmax model, where x stands for the exogenous variables. And in this second equation, y2t are the output variables and y1t are the input or exogenous variables. Then future values of y1t are influenced by its own past. Say from here, the past shocks are also involved here. And but it is not influenced by y2t. Then future values of the process y2t are influenced by both y1t and y2t, means the past values of y2t, because the second equation involves y1t also and the past shocks corresponding to y2t. Now, we define vector moving average process of order q. The process does not have any autoregressive terms. So, the process is yt equal to mu plus ut plus summation j equal to 1 to q theta j ut minus j, and then this is equal to mu plus theta b ut. Here theta b is equal to I k plus theta 1 b plus theta 2 b square plus so on plus theta q b to the power q. So, this is vector a process of order q. Then we consider vector MA1 process, the vector MA process of order 1, and we take mu equal to 0. Then by recursive substitution, yt is equal to ut plus theta 1 ut minus 1, then we write ut minus 1 equal to yt minus 1 minus theta 1 ut minus 2. So, you get ut plus theta 1 yt minus 1 minus theta 1 square ut minus 2, and so on. Then we get by recursive substitution theta 1 yt minus 1 plus theta 1 square yt minus 2 plus so on plus theta 1 to the power j yt minus j plus ut plus minus theta 1 to the power j plus 1 ut minus j minus 1. And if you take j tending to infinity and if you assume that theta 1 to the power j tends to 0 as j tends to infinity, then this process converges to theta 1 yt minus 1 plus theta 1 square yt minus 2 plus so on plus the last term is your purely random process ut. So, this is vector autoregressive process of infinite order. So, you have written this vector moving average process of order 1 as vector autoregressive process of infinite order. The only condition is that theta 1 to the power j tends to 0 as j tends to infinity. Now, you can write theta 1 to the power j equal to, say, you have some non-singular matrix P and say lambda to the power j P transpose, where this lambda denotes a diagonal matrix. Actually, this diagonal matrix lambda is the diagonal elements of this matrix lambda are the eigenvalues of theta 1. So, theta 1 to the power j tending to 0 means lambda to the power j tends to 0 as j tends to infinity. So, this requires that the eigenvalues of theta 1 are less than 1 in modulus. Means, say, suppose you have lambda this to the power j, this tends to 0 means what? As j tends to infinity. This means mod of lambda j is less than as j. Now, you take determinant of I k plus theta 1 z. So, if all the eigenvalues of theta 1 are less than 1 in modulus, then determinant of I k plus theta 1 z is not equal to 0 for mod z less than or equal to 1. And the reason is, suppose gamma 1, gamma 2, gamma q are the eigenvalues of theta 1, then determinant value of I k plus theta 1 z is equal to product j equal to 1 to q 1 plus gamma j z. So, you can write the determinant of I k plus theta 1 z in this form, and this is not equal to 0 for mod z less than or equal to 1. So, this implies that mod of gamma j is less than 1. Now, the autocovariance matrix of the process is gamma L equal to expectation of y t plus L. Then your y t is equal to u t plus theta 1 u t minus 1. So, you have expectation of u t plus theta 1 u t minus 1 and then u t plus L plus theta 1 u t plus L minus 1, you have transpose of this. Now, suppose you take L equal to 0, then for L equal to 0, you get expectation of u t transpose, which is equal to sigma, and expectation of u t minus 1 will be equal to 0, expectation of ut minus 1 transpose will be equal to 0. Then expectation of ut minus 1 ut transpose is also equal to 0, and then for the L equal to 0 you get this term theta 1 expectation of ut minus 1 transpose, which is sigma, and theta 1 transpose. So, for the L equal to 0 you get this expression. Similarly, for L equal to 1 you have gamma 1 equal to sigma theta 1 transpose, and this is equal to 0 for all L greater than or equal to 2. Now, we consider a vector MAQ process. So, we consider vector MAQ process y t equal to theta b u t. Then the process is invertible if it can be written as theta b inverse y t equal to u t, or y t minus summation j pi j y t minus j equal to u t, or theta z inverse is equal to I k minus summation over j pi j z to the power j, and summation over j equal to 1 to infinity norm of pi j is finite for the convergence of this theta z inverse. Now, for the invertibility, you have determinant of theta z equal to determinant of I k plus theta 1 z plus 1 plus theta q z to the power q. This is not equal to 0 for all mod z less than or equal to 1. So, the roots of determinant of theta z equal to 0 lie outside the unit circle. So, this is the condition for invertibility. Then you can write pi j's in terms of theta j's. Now, you have I k plus theta 1 z plus so on plus theta q z to the power q into I k minus summation j equal to 1 to infinity pi j z to the power j. This is equal to identity matrix. So, we multiply these two and then we write it equal to I k, and then we compare different coefficients of z or different powers of z, say. Then comparing the coefficients of different powers of z, we obtain the following recursive relations for pi j's. Say pi 1 is equal to theta 1. Say from here, what is the coefficient of z? You have theta 1 z and then in pi you have minus pi 1 z, and the coefficient of z on the right hand side is 0. So, you write it equal to 0. So, this implies that pi 1 is equal to theta 1. Then the coefficient of z to the power j comparing the coefficient of z to the power j on both sides, we have pi j equal to theta j minus summation I equal to 0 to j minus 1 theta I pi j minus I. for j equal to 2, 3, so on. Then for j greater than q, theta j is equal to 0. So, we take pi naught equal to minus I k and pi j equal to 0 for all j less than 0. So, this is how you can express different pi weights in terms of theta weights. Now, we obtain covariance matrices of vector MAQ processes. We have expectation of y t equal to mu and we take say mu equal to 0. Gamma L is equal to covariance between y t and y t plus L. So, this is equal to expectation of y t plus L transpose, and then this is equal to expectation of u t plus summation j equal to 1 to q theta j u t minus j. Then y t plus L transpose is equal to u t plus L plus summation over j theta j u t plus L minus j transpose. Now, for L equal to 0, you get expectation of u t transpose, which is sigma, then summation j equal to 1 to q theta j u t minus j transpose, which is again sigma, and then you have theta j transpose from here. And then you can write it as summation j equal to 0 to q theta j sigma theta j transpose, because you are taking theta naught equal to identity matrix. Then for L equal to 1 to q, you have expectation of u t plus L equal to 0. So, we collect only those terms which have say u t minus j transpose. And then all other terms have expectation 0. And suppose here you write instead of j, you write j dash here. So, t minus j dash equal to t plus L minus j you take, or j dash is equal to j minus L, or j is equal to j dash plus L. So, you take j equal to j dash plus L or j dash equal to j minus L. So, ultimately you get summation j equal to q minus L theta j sigma theta j plus L transpose, and then for the first term theta naught is equal to identity matrix. So, here you get sigma theta L transpose for j equal to 0, or you can write it as summation j equal to 0 to q minus L theta j sigma theta j plus L transpose. This is for all L equal to 1 to q, and for L greater than or equal to q plus 1, this is 0. So, this result is just parallel to the autocovariance function of moving average process for univariate time series. Now, we consider this bivariate MA1 process. y1 t y2 t is equal to u1 t u2 t minus, you have this matrix here u1 t minus 1 u2 t minus 1, sigma we have taken as 4 4 1 1. So, then we take determinant of 1 minus 0.2 z, then minus, then you have minus 0.4 here. So, you get plus 0.4 z, then 0.2 z, 1 minus 0.6 z. equal to, then you get this value of the determinant and then you write it equal to 0, and then you obtain the roots of this equation, and you observe that these are the roots and both the roots are greater than 1 in modulus. So, the process is invertible. Further, gamma 0 is equal to, you have theta 1 here, sigma theta 1 transpose. So, finally, you get this value of gamma 0. Then gamma 1 is sigma theta 1 transpose. So, you get this value of gamma 1, and gamma L is equal to 0 for all L greater than or equal to 2. Then we have V equal to the diagonal matrix 0.64, 1.28. Actually, you get the diagonal elements of V from gamma 0. These are the diagonal elements of gamma 0. Then the auto correlation matrices are, rho 0 is equal to V to the power minus half. Then you have this matrix gamma 0 here and V to the power minus half. So, you can easily obtain rho 0. Similarly, you can obtain rho 1, V to the power minus half. Here you have gamma 1, V to the power minus half. Now, we consider vector autoregressive process of order P. So, the vector autoregressive process of order P, VRP process, can be described as y t equal to delta plus phi 1 y t minus 1 plus phi 2 y t minus 2 so on plus phi p y t minus p plus u t. Phi i's are k dimensional square matrices for all p I equal to 1 to p. U t is k dimensional vector of residuals or vector of purely random processes at time t. Delta is the vector of constant term. Then you can write equation 1 as phi b y t equal to delta plus u t. Here phi b is equal to I k minus phi 1 b minus phi 2 b square so on minus phi p b to the power p. Then u t has mean 0 and variance covariance matrix sigma u. Expectation of u t plus 1 transpose is obviously 0. Now, this system is stable if and only if all included variables are weakly stationary, that is, all roots of the characteristic equation of lag polynomial are outside the unit circle. So, you have determinant of I k minus phi 1 z minus phi 2 z square so on minus phi p z to the power p not equal to 0 for mod z less than or equal to 1. And then you can also write this process 1 as y t minus mu equal to phi 1 y t minus 1 mu so on plus phi p y t minus p minus mu plus u t. And then you can easily verify that delta is equal to phi I mu and all mu is equal to phi I inverse delta, or phi I inverse is psi I. So, psi I delta. Now, under this condition you can write the system 2 as a moving average process, say y t equal to phi b inverse delta plus phi b inverse u t, or this is equal to mu plus u t plus psi 1 u t minus 1 so on. So, this is a moving average process of infinite order. Here psi b is equal to summation j equal to 0 to infinity psi j b to the power j, which is equal to phi b inverse, and psi naught is equal to I k. And then phi b mu is equal to, since the lagged value of mu is again mu, so you can write it as I k plus phi 1 so on plus phi k mu, or phi I k mu. Then the autocovariance matrices are defined as gamma y L equal to expectation of y t minus mu y t plus L minus mu transpose. You just write delta equal to 0. So, that mu is also equal to 0. Then gamma y L is equal to y expectation of y t plus L transpose, and then we write the value of y t plus L from equation 1. So, you get this is equal to phi 1 expectation of y t plus L minus 1 transpose so on, plus phi p expectation of y t plus L minus p transpose plus expectation of u t y t plus L transpose. And from here you get gamma y L is equal to phi 1. Here you obtain gamma y L minus 1. The difference between t plus L minus 1 and t is L minus 1. Similarly, here you get plus phi 2 gamma y L minus 2 plus so on plus phi p gamma y L minus p. And for L equal to 0, you get this last term also. You have for L equal to 0, you have expectation of u t y t transpose here, which is equal to sigma u. You can easily verify that expectation of u t y t transpose is equal to expectation of u t transpose, and this is sigma u. So, ultimately you get for L equal to 0 this equation 5. And then you get the Euler equations for vector autoregressive process of order p as. So, the first equation is for L equal to 0, you get gamma y 0 equal to phi 1 gamma y minus 1 plus phi 2 gamma y minus 2 plus 1 plus phi p gamma y minus p plus sigma u. You get from here. You also notice that gamma y minus L is equal to gamma y L transpose. Similarly, the second equation for L equal to 1 is gamma y 1 is equal to phi 1 gamma y 0 plus 1 plus phi p gamma y minus p minus 1, and similarly you get all these equations. Then these are the Euler equations for vector autoregressive process of order p. Then gamma I j L is the ijth element of gamma y L. This gives you the covariance between y I t plus L. Similarly, you also observe that gamma I j L is equal to gamma j I minus L. So, you have gamma y L is equal to gamma y minus L transpose. So, these are the individual correlation coefficients. You obtain rho I j L equal to gamma I j L upon under root gamma I naught gamma j j naught for all I and j, and then you can define the auto correlation matrix also. Rho y L is equal to v to the power minus half gamma y L v to the power minus half, where v is this diagonal matrix. So, in this lecture we have considered the multivariate extension of mixed Arma processes, that is vector autoregressive moving average processes. We also obtained the stationarity and invertibility conditions for the vector Arma processes. Then with the help of an example, we discussed how we can check the invertibility of MA process. For the autoregressive process, we have derived the Euler equations for the vector autoregressive process. It is actually the extension of corresponding Euler equations for the univariate autoregressive processes. In the next lecture, I will discuss the forecasting for the vector ARMA processes and the causality for vector ARMA processes. So, that is it. Thank you.
Hi, I'm Chitwan Lalji, a PhD student of Health Economics under the supervision of Dr. Debayan Pakrashi from the Department of Humanities and Social Sciences, IIT Kanpur. In one of my essays, I'm interested in understanding the relationship between consumption of fruits and vegetables and various health indicators. Health indicators, both subjective and objective health indicators like mental health, self-assessed health, various measures of blood pressure and various measures of cholesterol. Measures of blood pressure like systolic and diastolic BP, you have your incidence of high BP, MAP and incidence of high MAP. And as far as cholesterol is concerned, I have tried to concentrate more on total cholesterol, good cholesterol and incidence of high cholesterol. Now before I go on to what have been my major contributions and various policy implications, I would like to briefly tell you about the policy initiatives of WHO and various countries. The WHO, that is the World Health Organization, it started with a campaign of 5 a day. That is, you should have 5 portions of fruits and vegetables per day. That would be approximately, you could say, 400 grams of fruits and vegetables. Now, a portion, before we go further, I'll just tell you what exactly is a portion. One portion is equivalent to a medium-sized apple, or one small glass of fruit juice, which is approximately 150 milliliters, and maybe 3 teaspoons of vegetables. So, the WHO went with the 5 a day campaign, which was further taken up by various countries. Countries like UK, Netherlands, Germany, Norway, they adopted the 5 a day policy, while some went for expansionary dietary policies like France, Australia, Canada, Denmark. So, for example, Australia, it went for 2+5 policy, in which it said that you should consume 2 portions of fruits and 5 portions of vegetables per day. And USA went for a policy of fruits and vegetables more matters. That is, you must consume more and more fruits and vegetables. Now, irrespective of these expansionary dietary policies and dietary propagations, it has been found that only 28% of women and 25% of men, they actually meet the recommended dietary norms of 5 a day portion. So, the major contribution of my work is firstly to find an association between fruits and vegetables, whether there exists a relationship between fruits and vegetables and health indicators, and if they exist, whether due to heterogeneity in the data, so I will be doing it according to age, by gender and by your weight. So, apart from that, I will go for policy recommendations, in which I am basically studying how much fruits and vegetables matter. Apart from that, which type matters more. So, for that, I have taken data from the Health Survey of England. Health Survey of England is an annual survey which takes data, which conducts information regularly on demographic and socioeconomic characteristics. You have your lifestyle behaviors like an individual smokes or doesn't smoke, alcohol consumption, you have your sedentary and physical activities, and you have various health indicators also which have been collected. Before I go on to what exactly is my research, I would like to concentrate more on fruits and vegetables, like what kind of questions were asked in the survey. Questions like, what kind of fresh fruit do you eat? did you eat any dried fruit yesterday? Don't count dried fruits in cereals, cakes. Apart from that, for vegetables, they asked how many tablespoons of vegetables did you eat yesterday. So approximately after this whole survey was conducted, data was converted into portions of fruits, and like for example, 3 tablespoons of vegetables is equivalent to 1 portion. So data was converted and provided to the users, that is us, from the UK Data Health Survey. So the major contributions of my paper is that I found a strong negative association between intake of fruits and self-assessed health, then various measures of blood pressure like mean arterial pressure, high mean arterial pressure, high blood pressure, systolic and diastolic BP, and your total cholesterol. Apart from that, I have found a strong positive association between consumption of vegetables and good cholesterol. So it is recommended in a way that if you want to control your blood pressure, you must consume more and more fruits, and as far as vegetables are concerned, they impact your good cholesterol. Apart from that, I went in for a falsification test. A falsification test is basically conducted to know whether the model that you have adopted and the conclusions that you are drawing are not spurious. So if a falsification test is done to know, in a way it is tested by seeing an indicator, a health indicator which is not being impacted by your consumption of fruits and vegetables, and then we see whether there is significant result or not. If there is no significant result, that means your model is good and your results are non-spurious. So what we did is, for falsification test, we took ear complaints and infectious diseases. Now ear complaints, like if you are deaf since birth or you have some kind of imbalance, body imbalance, that is not being impacted by your consumption of fruits and vegetables, and we did find insignificant results. Apart from that, infectious diseases like HIV, AIDS, etc., we found similar insignificant results, indicating that our results are non-spurious. Apart from that, we went, since there was a lot of heterogeneity in the data, like by gender, by age and by weight, we did the regression analysis. We found results which stated that as far as fruits are concerned, it impacts a male's health more than a female's health. So it is basically said a man should consume more fruits to impact his health, whereas as far as vegetables are concerned, they impact a woman's health more. But this has been only seen as far as cholesterol is concerned, the various measures of cholesterol like total cholesterol, good cholesterol and your incidence of getting high cholesterol. Now after this, we went in for a policy implication, and in the policy implication we tried to find 2 policy implications: what matters and exactly how much portion matters. So as far as how much portion matters, we have found that on an average 5 or more portions of fruits impact your overall health, that is your self-assessed health, your MAP, your incidence of high MAP and incidence of high BP. But if you want to have a good mental health, so you can optimize your mental health by consuming 3 or 4 portions of fruits as well. And similarly, as far as self-assessed health and total cholesterol is concerned, an individual must consume 4 to 5 portions to optimally have the impact of consumption of fruits. Apart from that, vegetables have had a very little impact on your health. It only impacts your incidence of getting high MAP and high BP, and it's seen that only it impacts when you consume 5 or more portions of fruits. So an optimum consumption of 5 or more portions of fruits and vegetables are recommended, but fruits have a more impact on your overall health on various measures like self-assessed health, mental health, your various measures of blood pressure and various cholesterol levels. Another thing that we find is which type of fruit matters. It has been seen that all size fruits, they impact your self-assessed health, your systolic and diastolic blood pressure, your mean arterial pressure, your high BP and incidence of getting high MAP and high cholesterol. But we find that as far as frozen fruits or canned fruits are concerned, they help in regulating your incidence of getting high MAP or high BP, but it has a trade-off. That means there is something negative happening. It reduces the good cholesterol in your body. Apart from this, if you have an incidence of getting high cholesterol, it is recommended that you must consume fruit juices because it has a impact in reducing your probability of getting high cholesterol. and dried fruits, they impact your self-assessed health. As far as vegetables are concerned, very little impact has been seen. It has only been seen in case of portion of salads and its association with self-assessed health. Another thing that they have seen is vegetables in composite, they have an association with good cholesterol. So overall, my research basically says that there is an association between consumption of fruits and vegetables and various health indicators, and it is highly recommended that an individual, in order to be healthy, must consume 5 or more portions of fruits and 5 or more portions of vegetables per day, but fruits have a more impact on your overall health. Apart from that, all size fruits, they have a better impact on your overall health, your mental health, various measures of blood pressure and cholesterol. So, thank you.